Welcome to the walkthrough for assignment 2C. Unlike assignment 2B and 2A, where I read through the specification, I'm just going to highlight the key differences between this version and the previous version in 2B. In particular, in this third part of this three-part assignment, you'll be applying more advanced features of Java parallel streams in order to be able to write an app that knows how to obtain, transform, and store images. Everything else in this walkthrough is the same with respect to the requirements, with one main difference. Instead of implementing the parallel streams crawler 1.java skeleton, which is what you did in the previous implementation for assignment 2B, instead, you'll be implementing the parallel streams crawler 2 Java file. That's a file that's in the same folder, in the image crawler folder, as parallel streams crawler 1.java, and of course, sequential streams Java that you did for assignment 2A. And so what you'll be doing here is just filling out a different set of skeleton to-do markers, which I will then talk about momentarily. Other than that, things are pretty much the same. Of course, make sure that you've implemented things properly for assignment 2A, taking into account my comments. Make sure that you've got your unsynchronized array done correctly. Make sure you have your array collector done correctly. If those aren't working properly, then you're going to have a hard time getting assignment 2C to work as well. So without further ado, let's just wrap up this intro part and we'll go directly to talking about the skeletons. Now that we've walked through a bit of the specification, let me take you through the skeletons, starting with the appropriate files in the utils package. If you take a look at the utils package, you'll notice most of the files are the same as for assignment 2B, with one exception. The array splitterator has been moved out of unsynchronized array and into its own file, and that makes certain tests a little easier. So what you need to do is you need to copy your implementation of array splitterator from your unsynchronized array implementation from assignment 2B and put it here in this file. Nothing else needs to change as long as you address any comments I had for assignment 2B, either in the comments I give on your code or the frequently made mistakes. Unsynchronized array, of course, should be essentially the same thing as you did for assignment 2B with the array splitterator split off. If you're a grad student, you'll have to fill in the synchronized array class. That should be straightforward. That's the same as before. If we take a look at array collector, you'll have to make sure that you implement array collector correctly. Once again, incorporating any comments and suggestions for improvement I gave to you or I used in the frequently made mistakes files that apply to you in the analysis therein. So that's basically what utils is all about. Let's now go over here and take a look at the skeletons for crawlers. So once again, there's a number of files here. Obviously, please copy in your implementation of sequential streams crawler from assignment 2A, making sure to incorporate any comments I gave you, either directly or through the frequently made mistakes analysis. Likewise, make sure you copy in your implementation of parallel streams crawler 1, which, as you no doubt noticed, deliberately was almost identical to sequential streams crawler modulo, replacing stream with parallel stream, that little minuscule change that we talked about. The interesting implementation, however, is in parallel streams crawler. And you can see this is going to be somewhat more sophisticated than parallel streams crawler 1. So parallel streams crawler 2, which is the file we're looking at now, is a more advanced implementation of parallel streams than we saw in parallel streams 1. So if you take a look at this file, you see there's a number of methods to implement, not just a couple. And we'll start first by talking about the crawl page method. So crawl page is going to use Java parallel streams in order to download and process images on this page, and then recursively crawl other hyperlinks accessible from this page. And it'll return all the numbers that it accumulates successfully as the return value. The first thing you'll have to do here is get the HTML page associated with the page URI, which is passed in here as a parameter, and make sure you handle the null return value. If you get back a null for some reason, make sure you just return 0 and don't go any further. If you don't get back a null, then you're going to write a Java parallel stream that will ultimately return the number of processed images reachable from that URI by the following steps. So the first thing you're going to do is you're going to create a stream of 2 Lambda functions using this factory method here called stream of tasks. We'll talk about stream of tasks in a minute. It's very important that you call stream of tasks here, because otherwise there's no easy way to mock the testing for the white box test that we do. As you'll see, this stream of function lambdas comes back where one will process images on a page and the other will process hyperlinks on each page. You then go ahead and run these stream elements, these lambda functions, in parallel using the .parallel method from the streams interface. And then you'll go ahead and take each of those lambdas and map the results to an integer. And that'll use, of course, the map to int method we've talked about before. And then you go ahead and sum the results. So that's what this method will look like. This method, as I mentioned before, we'll call stream of tasks, which is this factory method that will create a stream of functions. And you're responsible for creating that stream of functions. That's a hint, stream of functions. And what you'll use here to create these function lambdas will be these pair of factory methods that appear below. So there's one factory method called make images on page function, and there's another factory method called make hyperlinks on page function. And this particular method will create a stream that will have those 2 factory methods used here in the stream. And make images on page function is a factory method that will construct a function lambda to process all the images on the input page. And we'll talk in a second about sort of how it does that. And what it's going to do is it's going to receive a page and then get and process all the images on that page and return a count of the processed images. And we'll see how that's going to work in a second. You have to write the return value here that replaces null with the appropriate implementation that returns a function lambda. That's a little bit interesting to do. Likewise, make hyperlinks on page function is a factory method that creates a function lambda to crawl all the hyperlinks on a given input page. And again, you can see here we give it sort of the depth that's passed in here. And this particular method is going to do some magic to make all this stuff work properly. So it's going to receive a page and recursively crawl all the hyperlinks that are on that page and count the number of processed images from each hyperlink. And you'll have to pass in the depth value to keep track of how far along you are in the recursion. So those are factory methods. Now here then are the methods that actually do the work that are going to be what are going to be returned from those factory methods as part of the function lambdas. So one method is called crawl hyperlinks on page. And this is going to recursively crawl all the hyperlinks that are on a given page at a given depth. And this is going to require a little bit of work. So you're going to use a Java stream that will invoke the perform crawl method to crawl through the hyperlinks on the page and return the total number of processed images. And the way to do this is to make a Java parallel stream that has the following steps. First, you're going to get all the hyperlinks on this page as an array of strings. Then you're going to convert that array to parallel streams. You're going to call the helper method, the appropriate helper method, to crawl each hyperlink and map the result to an integer. And then finally, you're going to return the total number of processed images. So this gives you kind of a hint as to what the steps are to do. And it's important that you do all these steps. Here's the process image, or rather process images methods. You can see this takes an array of URLs, and it's going to go ahead and download, process, and store each image in this URLs array. And internally, this will have a Java parallel stream that will do the following things. It'll convert the URLs array into a parallel stream. It'll map each URL to a downloaded raw image. Then it'll ignore or filter out anything that's not non-null. Then it'll convert each downloaded raw image to a stream of transformed images. It will then ignore any null transformed images. And finally, it will return the number of successfully transformed images. So this is a rather involved parallel stream. Here's a method called transform images, transform image. This is going to download, process, and store one image by applying all the listed transforms to it, all the available transforms that are in the M transforms field. This will also use a Java parallel stream that will convert the transforms array, or really the transforms list, into a parallel stream. It'll then attempt to create a new cache item for each transformed image, filtering out any transform image that's already been locally cached. It'll then apply the transform to the original image, producing a transformed image. And finally, it will return a stream of all non-null transformed images. So you can see here it's going to get rid of any null images. And it's going to return this as a stream. So this is rather an interesting type of method. It doesn't return a primitive, doesn't return an int, it returns a stream. So that may be something you haven't seen in some of the other implementations, so you may have to puzzle that a little bit. So essentially, those are the various methods, and you can see you're going to have to sit there and kind of scratch your head and see how this all works out and play around with it and think about it a while. And when you're done, you'll have a much more sophisticated and advanced form of a parallel stream implementation of the image crawler app. And it's really quite interesting, and it's fun to compare and contrast how this version performs relative to parallel streams crawler1.java. So that's the end of the walkthrough of the various skeleton files. Now that we've examined the specification and the skeletons, let me show you how to run the unit tests. If you go into the tests folder under image crawler and you right-click on tests in edu Vanderbilt image crawler and type run, it'll go ahead and build and run the tests. As you can see, there's quite a battery of tests here. There are tests that test the parallel streams crawler 1 implementation, the test that tests the parallel streams crawler 2 implementation. We've got the sequential streams crawler test. We've got the array collector tests. We've got the synchronized array tests for the grads, the array collector test for ugrads, and then a whole bunch of other tests for various other features. So this basically tests everything under the sun that you've done so far, and naturally everything should go ahead and have a green check mark by it indicating that all is well. So that's how you go ahead and run the unit tests, and this is what they should look like if you pass them all, which hopefully you will. Now that we've seen the unit tests in action, let's take a look at what happens when we run the app itself. Again, there's a couple different ways to do this. One way is to go into the apps directory and go and run the Android tests, which will go ahead and do instrumentation tests. I'm not going to do that in the interest of time, but you should probably do those when you're running your tests just to see how they all work. What I'm going to do instead is go into the app in my emulator, and you can see as usual, you can select between the different implementations we've done. You can do the original sequential loops implementation, sequential streams, parallel streams 1, and parallel streams 2. Just for kicks, let's go ahead and do sequential streams. And you can see again that things proceed sequentially, essentially downloading and applying the transforms to each image, one image in one thread at a time. So it's a little bit slow. Let's now go ahead and crank up the parallel streams 1 implementation. This is what you did for assignment 2B. And you'll see when we run this, look how much faster it is. It's much, much faster. And that's because it's taking advantage of the actually 6 hyper-threaded cores on my laptop. So it's pretty darn scalable. So let's go ahead and stop that one. And now let's go ahead and select parallel streams 2. And that's the implementation that we're doing for this particular version for assignment 2C. And again, you can see how fast it is. It's extremely fast as well, arguably faster than parallel streams 1, although we'd have to really sit down and do some benchmarking in order to see which one runs faster. A couple things that are worth noting here. It'll tell you how many threads are being used. So you can see that this test is running, and it took about 16 seconds or so to process 112 images, and it took 22 threads to do that. Those are threads in the thread pool that's being used under the hood. Let's go back and just for kicks, let's try running parallel streams 1, and we'll see how long it takes to do that, and we'll see how long it takes to how many threads that it uses as well. And again, you think you can agree it's also running extremely fast, and actually uses 25 threads. So that took about 13 seconds. So your mileage may vary. If you were to go back and rerun these tests, couple different times, you might get different results because you'll be seeing the results of caching, and because everything runs in parallel, it's not necessarily going to take exactly the same amount of time each time. And I think you can see here that we're running these tests, and I think it's taking roughly about the same time. Now it's using 28 threads. So once you've got parallel streams taking place in the background, things run very, very fast, much faster than running sequentially. So I encourage you to try running the different versions, see if you can tell a difference in how the results are processed, see if you can tell a consistent difference in how long it takes to get the results. And naturally, your mileage may vary depending on how much memory you've got, how many processors and cores you've got, and other factors that will make a difference in terms of how the system actually behaves at runtime.